right. All right. If you don't have a handout, there's handout here. There's also handout going around. Handouts. We will not be doing that immediately. All right. Okay. Hi, everyone. Hello. How do you do in physics? Yeah, no. All right. Yeah. So we'll wait for a few more people to sit down, I guess. Right. Hello. So I think, is that like the last Monday midterm of the semester? I would hope so. Yeah. It's not. All right. So the slides are like week 9 plus 10. So we're doing it this way today. So the plan is first to talk about deep copy versus shallow copy. This is something that we've done. Thank you. Can you like keep passing it around for a while because there's people still coming? Yeah, that's like the engineering solution. It's like keep it circulating. Okay. So we'll talk about that. We'll do exercise C, which I came up with a couple years ago, and like without false modesty, some of my best work is exercise C. And then we'll start a new topic, algorithms. Hi, I'm starting the actual lecture. You have a question? Thank you. Speaking of things falling, Professor David James, former chair of engineering science, is going to have a demonstration of, well, it's going to be a surprise on Wednesday. So something to look forward to. Another thing, I had a quiz on Friday specifically for my friends who decided to come to lecture rather than do like, I don't know, like BS pendulum things. And just kidding. The quiz is still open. So if you want to be my friend, you can go on Quirkus and do quiz number 5. It's not hard. One more thing before I start the lecture, actually. How many people have started project 2? All right, this is great. If you're stuck, we're going to have sometime in the middle of the week, I'm going to have like an extra session if you're stuck and can get going. And then in addition, so the test cases right now are hidden. As you see on Gradescope, you get feedback out of 88.5. We will reveal those test cases tomorrow. And then those will basically be what you're graded on. However, we will add another 12.5 worth of test cases after the fact, just to keep it fun. So that at the end, it's going to be out of 100. All right. So questions about anything before I start my stuff? No? Okay. So sorry, quiet down, please. Like the physics midterm, like you don't need to discuss it. It already happened. So maybe talking about something else. So let's think about this kind of example. So if you have a list of lists, so A here is, 1, 2, 3, 4, and then you say B equals A. So what this does is it just makes B is now an alias of A, right? That means that like B, anything that you want to put there is just literally the same as A, anything you want to put there. So to be clear, like if anything is an integer, that is true, but like anything there would be the same because A and B are just the same thing, right? You can do what's called a shallow copy. This is specifically for the case of a list of integers, where you say B is this new list, and the first item in the list is A0, and the second item element is A1. And this is the same as A with the slicing notation. A lot of the time, people just think about the slicing notation as like, this is the shallow copy. Technically, it's like this, right? So if you say like A is, I'll make it a list of lists. Stick an integer there as well. So I can say A from 1 and up to the end. And what would it be? Or run this. This would be just this list, right? So what this means is it's just a shorthand for saying a new list that's A of 1 and A of 2, and that's it because this is how many elements there are up to the end. If you're saying something like A colon, that just means A from beginning to end. So that's the same as A at 0, A at 1, A at 2. Those are literally just the same thing. Make sense? But people think about this as, the shallow copy notation. So what do we mean by shallow copy? What we mean is that B at 0 is now an alias of A at 0 because we have not created a copy of A at 0. We just said B at 0 is now going to be equal to A at 0. So what does that mean? It means that if I say B is equal to this, so ID of A and ID of B are different. They're different lists. However, ID of A at 0 and ID of B at 0 are the same. So that means that if I go B at 0 is equal to 5, then I print A and print B. So what's going to happen anyway? I mean, I'm setting it up so that something would happen. So what could happen? Anyone? You could just run it. Yeah.
5, 2, 3, 4.
Yeah. Yeah. So both are going to be changed. So this is the new A and this is the new B, and they're the same. Why is it that they're the same? Well, the way I think about it, and I'll show you the Python tutor picture in a second, is just in the code, this list was never actually copied. So when I say B at 0 is equal to 5, I'm changing this guy because there is only one copy of 1, 2. So that is how I think about it. There's multiple ways of thinking about it. You can do the table, which we'll do in exercise C, or you can think about it like this, or you can think about it in terms of the diagrams. So I'm going to pythontutor.com. I'm copying and pasting this code into there. So here's what's happening. So A has 3 elements. So the first element is the list 1, 2. The second element is the list 3, 4. And then the last element is 5. Now we're saying B is a shallow copy of A. And this is what that looks like. right? So my way of thinking about it is the list 1, 2, and the list 3, 4 here in the code, we never copied them, so they're still there. Another way of thinking about it is this is A at 0. And this is also B at 0 because that's what the shallow copy does, is it just says B at 0 is going to be the same as A at 0, and B at 1 is going to be the same as A at 1, and B at 2 is going to be the same as A at 2. And that's what it is. And that means that when you go and say B at 0 at 0, this guy is equal to 5, well, it's going to become 5. Make sense? So that's what a shallow copy is. It's a separate list, in general, a separate object, so it could be a separate dictionary. But if you go and modify the contents of it, the contents are going to change for both the original list and the shallow copy, because the list inside just have the 2 elements. Okay, someone's tagging me. So the question is, so outer lists have different addresses, but the elements have the same address. Yeah, you could put it that way, I think. So that is a correct way of putting it. I will restate it. So this is like not easy stuff, obviously. So the way I would put it, sorry, quiet down, please. So the way I would put it is B and A are separate lists. So this is what you refer to as them having separate addresses. So they're just different lists. However, A at 0 is equal to B at 0, A at 1 is equal to B at 1. And what we mean by equal is that they're the same list. So of course they have the same address because they're the same list. So it's not about, I guess my objection to that phrasing, which was correct, but just like I would object to it a little bit, is it's not that the inner lists have the same addresses, it's that the inner lists are the same lists. So naturally, like I have the same address as myself, right? It's just that some people call me Mike and some people call me Professor, whatever. But it's still me. Make sense? All right. Oh, I'm out the bathroom. Hold on. So questions about this? Yeah. Yeah. So the question was, why does the slicing make it different? And the answer is slicing is just shorthand, right? So slicing is shorthand for this. Right? So like that's literally what the slicing means. And what this says is B is a new list. So the outer square brackets say I'm making a new list. And then here I'm saying, you know, the elements are A at 0, A at 1, A at 2. So we just copy in the memory table, which we'll see in exercise C, we just copy the address for A0, A1, A2 into here. So the way to see it in the diagram is A at 0 is this list, and also B at 0 is this list. So the question was like, why does A change? And the way I would put it, it's not that A changes, it's that the contents of A change, right? And then the contents of A are, you know, the same as the contents of B. So it's as if, you know, so let's say that this is, you know, my cup of coffee, but also your cup of coffee, and it has coffee in it. And then I say, well, like spill the coffee out of my cup. Well, if you spill the coffee out of my cup, we are also spilling the coffee out of your cup because it's our shared cup. Okay. Make sense? Yeah. Okay. Weird example, but actually, we'll see on Wednesday something that's kind of brought it to mind. So yeah, gonna be exciting. All right. So that's the demonstration that we're going to have. All right. So does that make sense? Okay. So that's shallow copy. So to summarize, this kind of thing is a shallow copy, creates a new list, but the sublist of B, or what the person on Discord called the inner lists, they're aliases. So how do we make two independent lists that are not the same at all? Well, here's how. So you can say, I have this list A, and then I'll have, sorry, quiet down, please. And then, hello, what is that? And then I have a new list B. And then what I'll say, oops, is just go through the sublist of A. So make the sublist initially 1, 2, and then make the sublist 3, 4, and append a copy of the sublist to B. So I guess you probably can't copy and paste from the slides, so let me just retype it. So I'm going to say B is initially nothing. And then I'm saying for sublist in A, B append copy of the sublist. So let's see how that goes. Online courses for $500 seems like a good deal, actually. Okay. The people on YouTube, they're paying way more. Okay. So we have A, and A is, oh, I have a 5 here, which is not good. We'll get to that in a second. So I have A, and A at 0 is this list 1, 2. A at 1 is this list 3, 4. Guys, write down. Thank you. And now what we're saying is sublist initially, it's going to be the first element of A, and then it's going to be the second element of A. So now sublist is going to be 1, 2. Right? So the same 1, 2, that's A at 0. And then we're going to make a copy of this. So this is going to be a shallow copy, but we don't care because you cannot multiply the contents of an integer, right? So going to make a copy of this and going to stick it in B. Make sense? And now sublist is going to be 3, 4. So the downside of the diagrams is like the arrows get confusing. So sublist is 3, 4, and also A at 1 is 3, 4. That's the same list. We're going to make a copy, and we're going to append it to B. So we're going to make a copy of 3, 4, the same way that we made a copy of 1, 2, and we're going to append it. And what you see now is, okay, so we have A, and we have B, and they don't have anything to do with each other, at least as far as this diagram is concerned. Does that make sense? Yeah.
Copies of the list of A instead of making points of the list of A.
Right. So what we're doing is we're saying sublist initially is 1, 2, and then sublist is 3, 4. And then over here, we're making a copy of sublist, and we're appending it to B. Does that make sense? Yeah.
So a copy of sublist is not sublist itself.
Correct. So what you're saying is a copy of the sublist is going to into B, and that's exactly right, because we're saying sublist slice. And what this does is it creates a new list. So it's as if we're saying, So that's the same as saying, sublist at 0, sublist at 1. Of course, that's more convenient because this would work with sublists that are not of length 2. But this and this, they're the same thing. So here, what we're doing is we're creating this new list, and the elements of the list are sublist 0 and sublist 1. Yeah. So the question was, what would happen if I took out the slicing? So what would happen if I did this? And the answer is, this is just a slower way of doing a shallow copy. So let's do that. That's actually a good question. So here, sublist is what? Sublist is, wait, did I? So, okay. So sublist, why is sublist the second element? Oh, because it's like rearranged anyway. So sublist is 1, 2. And then 1, 2 is what? 1, 2 is A at 0. So that's this arrow over here. Does that make sense? So A is this guy. And I think this arrow, the reason I'm confused is this arrow is like duplicated. So this is sublist and this is also like A at 0. Okay. And now we're saying append sublist to B. So what that's going to do is B at 0 is also going to be this list, because we never make a copy of it. We're just saying B at 0 is now also going to be the list. Make sense? So, okay. So that's what you would call a deep copy of this particular kind of object, right? So one issue that I kind of alluded to is that this kind of hides some of the details, because really, and this is maybe not necessarily what you need to know. What you need to know is really so if I change so inline primitives means that yes. Sorry, let me finish and then I'll answer your question. Sorry. So inline primitives means that the integers are just located in the list. Really, the integers are the same as list. They also have addresses. So I'll just change this to render all objects. Okay. And what we're seeing now, so right now, 1, 2, 3, 4, they are only referred to in one way. But once we have done this, oh my God. So once we have done this, what we see is, sorry, so this is the shallow copy. So I'll change it to the deep copy again. Sorry about that. So what you see here is there is 2 arrows to 1 now. This is extremely confusing, but the cost maybe no point in thinking too hard about it. But the point is 1 also has an address. So what this is doing now is it's displaying the fact that 1 also has an address by saying, well, 1 lives somewhere, and if A at 0 and also B at 0 are 1, then that is reflected in this error and this error here. Because really, 1 is the same as a list. It's just that it happens to be an integer. Does that make sense? Questions? Okay. Yeah, you had a question. Yeah. Yeah. Yeah, so like the question was like, is it kind of like the is a deep copy in this case a shallow copy of a shallow copy? Yes and no. So if I take you literally, then no, because if you do, A is 1, 2, doesn't need a second element, and then you say B is a shallow copy of A, and then you say C is a shallow copy of B. I guess that would be the shallow copy of a shallow copy, right? And no, like here, A and B and C are all shallow copies of each other, right? So what we mean by that is A at 0 is an alias of B at 0, and also A at 0 is an alias of C at 0. And the same for B and C, I guess. Does that kind of intuitively make sense to people? So the intuition here is we're never creating a copy of the inner list 1, 2. We're just saying make B a new list and then make B be A at 0. And then we say make C be B at 0, which is the same as A at 0 because they're aliases. Yeah. So a shallow copy of a shallow copy is still a shallow copy. But your intuition is not wrong, right? Like we're kind of doing like make a copy and then inside making a copy, make individual copies of the sublists. All right. Okay. Anything interesting on Discord? Where can we hide the handout if we're online? That's actually a good question. I'll type in the question from the handout. Okay. So does this make the list completely independent of each other if you modify one of them? Yes. So that's what the deep copy is it's making a completely independent, separate copy of the initial object. So the one kind of caveat there is that really A at 0 is an alias of B at 0 in the sense that they're both referring to the integer 1. It's just that you can't help it, and it also doesn't matter because you cannot go and change the content of the integer, unlike with the list, because that's immutable. Make sense? So this is where kind of the diagrams obviously fall short. This is, I don't think, illuminating, except to say that it's very complicated. So that is why we're going to do exercise C right now. Except I want to do, how do you do a deep copy of a list of lists of lists? I think that was a question that someone asked, right? So first of all, what's a list of lists of lists? Well, it's a list of lists of lists. I'll put a 0 here or something. And I'll put a 1 here. Okay. So first of all, what if we try to do the same deep copy thing as we've done before? So I'll go B is the empty list, and then I'll go for sublist in A, append a shallow copy of the sublist to B. And do it. So this is A and this is B. That's fine. But if I go B at 0, at 0, at 0, so that is this guy, is equal to 42. And then I print A and I print B. I think you know what's going to happen. Did not work. So the intuition for why it did not work is we're saying sublist, first it's this guy, and then it's this guy. And we're saying make a shallow copy, make a shallow copy of this guy and make a shallow copy of this guy. But what's the shallow copy of this guy? It's so sublist initially is going to be this. And a shallow copy is this guy, sublist 0. So we are not really creating a copy of this. We're saying append this new list, which contains sublist 0 as the element to be. So that means that if I go and modify this guy, well, that means I'm modifying this list of which I've never created a copy. So let's do it in Python Tutor. So what do we have? Sorry, so I'll remove the stupid primitives. That's much neater. So what is sublist? Sublist is this guy, which contains 0 as the element. And then when I append a copy of the sublist, this list is still the same. So this list is now A at 0 at 0, and it's also B at 0 at 0. So A at 0 at 0 and B at 0 at 0 are aliases. So I change one, the other changes in one. Does that make sense? Questions about this? All right. So what about something arbitrary? So if I say something like this would just crash. The reason this crashes is I'm trying to make a shallow copy of 1, but that makes no sense. Like this is not really shallow copy. This is like slicing notation, which just works with lists. So how to do this? That would have to wait either for the last week of this class or for the first week of ESC180. We'll see how things go. Okay. So that is not something that we solved so far. So if we know the structure of the list, we can make a deep copy. If we don't, then we don't. How do you make a deep copy? Well, instead of doing this, what you would do is, sorry, so that's the one that doesn't work, and I'll just do the one that does. So here, B is the empty list. We're saying for sublist in A, and then this is the sublist. So we want to create a deep copy of this guy. How do we make a deep copy of this guy? We say new sublist is initially nothing. And then we say for sublist 2 in sublist. New sublist. Append a copy of sublist 2. And now once we're done, we append new sublist to B. So the concept here, I typed it a little bit quickly, but what's the concept? The concept is we're saying make a deep copy of this guy and make a deep copy of this guy. We know how to do that. This is just a list of lists. And that is what we're doing here. Like I'm just doing like a deep copy of this guy, and I'm doing a deep copy of this guy, and I'm appending those in turn. Does that make sense? So the concept is so this is just a combination of a technique that we already had, computing a deep copy of a list of lists. And then we're just doing it for the first sublist and then for the second sublist. Right. So this is code that you've seen already, and that's kind of not hard code. Yeah. Questions? All right. Let us do exercise. So so for the people at home, I think I'm going to type it and I'm going to paste it into Discord after I type it. So I'm going to give you kind of a few minutes to kind of look at it and hopefully start a little bit. And then I'll get you started and then we'll, I guess, finish on Wednesday. Two minutes and then we'll get started. All right, it's 5:55. So we'll get started in the interest of time. So what's going on here? First of all, we are creating this list. In order to create this list, you need to place 5, 6 in memory. And in order to do anything, you need 5 and 6 and 7 in memory. So we'll first place 5 and 6 and 7 somewhere. As we know, technically in Python 3, they will be in predefined places, but they're somewhere. So now that we have those, we can create the inner list 5, 6. So that would be at 1000 at 1040. So this list 5, 6, you need to create it. You need to put it somewhere in the memory table, but it doesn't have a name except L at 0, but we haven't created L at 0 yet. We haven't created L yet, rather. So now that we have this, we can create L. So L is going to be at 1100. And then it also has 7, so at 1080. Does that make sense? So that is now L. So we now get to go into the variable table and say L is at 1120. So of course, kind of those numbers are somewhat arbitrary. So I will never ask you to write out the table. I will ask you to predict what's going to happen. But kind of grading the tables is a big mess. Don't want to do it anyways. So it's not as if you can like check your answer because like some of those are made up. You could choose to place 5, 6, 7 somewhere else, right? So anyway, this is L. So now we're going to create L1. So square brackets on the right means that we're creating a new object, a new list. And L at 0, we're not making a copy of it. We're just saying L at 0. So new object, we got to place it in the memory table. And then what's L at 0? Well, it's wherever this 5, 6 lives. Where does 5, 6 live? Well, it's this guy, so it's at 1100. All right. So what we have here is we have the list L, whose first element is the list at 1100. And we have the list L1, whose first element is also the list at 1100. So that means that when we go and change L1 at 0 at 1, L1 at 0 is this list at 1100. L1 at 0 at 1 is this guy, and we're saying it is now 1080. Okay, that means that L at 0 at 1 is also 7. On the other hand, what are we doing here? We are creating a new list. So again, go in here and create a new list. And this new list is going to have at 1080, right? So the 7. And then we're saying L1 at 0. Sorry, I forgot to place L1 in the variable table. So L1 would be at 1160. And we're saying L1 at 0. So this guy, it used to be something, but now it's going to be this new list. I could choose to make it like this, but it's like this list. So it's this new list that lives at 1180. So this becomes and of course, that means that L doesn't care about this guy. Right? So that means that what is L now? Oops. So it started as 5, 6, 7, and then this actually changed the contents. So this became 5, 7, 7. And then this didn't matter. So L1 was also this, and then L1 at 0 became 7. All right. Okay, I'm sorry. It's 6 o'clock exactly. Last midterm on the Monday. I expect everyone is going to be here fresh and ready for the 5 o'clock lecture next week. I will see you. Bye. Thank you.